This week in class, we talked about how to describe data, both visually by building up histograms and frequency tables, and also by boiling all our data down into single numbers, specifically measures of central tendency and measures of variability or spread. And given those numbers, we can describe a great deal about what our data is, what the properties are, and what the histograms look like. So first of all, let's assume that we have a group of data that we've collected, and we want to organize it into a table so that we can build a histogram from that data. This histogram is called a frequency histogram, and all it's going to tell us is how often each score occurred. I might go out and measure something like happiness levels, or on a scale of 1 to 10, how do people feel about the IU football team, and from that I can quantify how often each of those variables was observed. So let me give an example. In this case, I am using a program called R. In the comments section underneath this, I have a link to both the R website and another tutorial which shows you how to install it. This isn't necessary for any homework, this is just for demonstration purposes. You don't need to install it, but if you feel like it would be helpful to have it and follow along as I do this, feel free to do that. So some of these I'm not going to go through what every command means, but I'll just try to show how it relates to what we talked about in class. So here all I'm doing is I am basically building up a bunch of data. So let's say I observed values 1, 3, 4, 5, 2, 3, 4, 5, 1, 4, 2, 5, 1, 1, 4, 4. Okay, so these are just some random numbers that I've collected. And in this case, if I just type X, it shows me all the values that I put in there. And remember, the first thing to do is usually to sort everything. In R, this is very easy using a command called sort, so it just sorts everything from smallest to greatest. Now, if I wanted to build a frequency table, I just type table and then parentheses X, so all the numbers that I put in, and you'll see the values on the top and then the frequency counts on the bottom. So 5, 2, 2, 5, 3. And if I actually counted these up, for 1 I'd have 1, 2, 3, 4, 5 of those occurrences, which is marked down here. For 2 I'd have 1, 2 occurrences marked down here, and so on. Just like those tables that we built up in class. Now if we wanted to build a histogram, remember there are 4 distinct steps. First, we have to actually make 2 axes, so one where the x values go from smallest to largest, and also a y-axis where the frequencies go from 0 to whatever the maximum frequency is. Then we take each of those observed values and then we build up a box, the height of which is at the very level where the frequency is. Okay, so let me show you what this looks like in R right here. Okay, don't pay too much attention to these different options I'm putting in here, but if you want, you can also plug this in as well. So let's see here. Let's see if this works. Yeah. Okay, so I've just built up a histogram. This should look like a frequency table if you mark this up on your own. So for 1, I have 5 occurrences of 1. For 2, I have 2 occurrences. For 3, I have 2 occurrences. And for 4, I have 5 occurrences. And for 5, I have 3 occurrences. My frequency table. So that's how we would describe something visually by building up a histogram. But we could also describe this, all this data that we've collected, using single numbers. And the first one we're going to focus on is measures of central tendency. Remember, there are 3 major ones: the mean or average, the median, and the mode. And the mean is used most often. So here in R, I can just type in mean, and that is going to give me the average of all these values. If I wanted to use a notation that we use in class, remember that the mean is equal to the sum of all the values that we've collected divided by the total number of values. So the actual length of X is the number of values. So I have 17 total distinct observations right here. And I'm going to call that N, which is the notation we used in class. So also remember, for the numerator, we need to sum up all these values and use that for our numerator. Remember, in class I was represented by sigma x, and in R we just notate that by sum x. So let's call that sum of x equals sum x. And now I can say mean x equals sum of x divided by n. And if I just enter that again, that's going to give me the same value I had right here. I'm just reorganizing it with the notation that we used in class. I can also use the median command, and that's going to return a value of 3. So remember, the median just simply splits the number of observations into 2 equal halves. In this case, I had 17 values, so I just find whatever value is right in the middle. So in other words, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's going to split so that there are 8 values to the left and 1, 2, 3, 4, 5, 6, 7, 8 values to the right. Remember, if I had an even number of values, let's say I added on one more value, the median would be between these two values right here. In other words, 3.5. I just take the average of those two numbers right there. Finally, the mode, I can just see from this table that I spit out right here. And in this case, there are actually 2 modes. This is a bimodal distribution. I have 5 observations of the value 1 and 5 observations of the value 4. So in this case, there are 2 modes. And if I look at my histogram right here, that's where I see the tallest frequency bins. So I see that for 1 and for 4, and so there are 2 modes. It is a bimodal distribution, or histogram, with 2 distinct peaks. If there was only one distinct peak, that would be what's called a unimodal distribution. I could also have something called a skewed distribution, in which case I would have a noticeable tail, say to the right, in which case it would be a right skewed distribution, or a distribution skewed to the left, which would be a left skewed distribution. Lastly, just one more way to describe these distributions. If it's a totally uniform distribution, if there are no clear peaks anywhere, or if every value occurs with an equal frequency, we call that a uniform or non-modal distribution. There is no mode. The last thing I want to say about measures of central tendency is that although the mean is the most commonly used measure of central tendency, it can be very susceptible to outliers. So again, if I just build up a very simple frequency distribution like this, where most of the values are in the 1 to 3 range, but I add a value of 1,000, and then I take the mean of x, the mean is going to be very far removed from where the majority of all the values lie. In this case, a much more sensible measure of central tendency would be the median, which is 2. So that's measures of central tendency. In the next video, we'll cover measures of variability, specifically standard deviation, which gives you a sense of how spread out that distribution is.